So in today's session, we're going to be working with AS Math Quadratics. We're going to be walking through the subtopics in this chapter part by part and provide some examples. At any point, if you feel like I need to repeat something or explain something once again, please let me know by raising your hand, okay? So let's start. The first thing we must know for this chapter is the standard form of an equation. So the standard form says that in an equation, there must be y is equal to ax squared plus bx plus c. Okay. From this equation, whether it be any form, the values of a, b, and c can be anything at all. From this equation, we can find two things. Number one, the a's value tells us the shape of the curve. The shape of the curve. And by the shape, we mean it's either going to be like this or like this. Okay. And secondly, from this c, the value of c tells us the y-intercept. So I'm going to show you an example real quick. The first example is going to be, let's say y is equals to 3x squared plus 5x plus, let's say, 2. Okay. From this curve, or like from this equation, I can tell two things. The first thing is, since the coefficient of x squared is 3, that means a is equal to 3. And since this a gives me the shape of the curve, we happen to know that if we have a as a positive number, then our graph looks like this. And if our a is a negative number, then our curve looks like this. Okay, that's the first thing we know from this equation. So this positive value of a equals to 3 tells me that our curve is going to look like this shape. Open-ended on the top half, or a smiley face, or any other name that you want to give this curve. It's completely up to you. But all that matters is that you remember the shape. The second thing that this equation tells me is this plus 2 is the y-intercept. So that means when I'm intercepting the value of, or the y-intercept, this point is going to be y equal to 2. I hope that makes sense to you. So if this is the axis of y and this is the x-axis, the curve is going to intersect the y-axis at y equals 2. So even before I start working out with this equation or find any other information, just from these two parts, I can tell that the shape is going to be like this. And secondly, the y-intercept is going to be here. So that's what the value of a and the value of c tells me from this standard form. Okay, can we all move on? Okay, thank you so much for acknowledging me. For the second thing, for the second type of equation, we're going to learn the vertex form. The vertex form, more commonly known as the completed square. Completed square form. The completed square form gives us a curve or equation in the form of y equals to a x minus b whole square plus c. Be very careful that this b is a negative value and not a plus. Okay. Again, this tells me a couple of things even before we start working with the equation. So this a, once again, gives us the shape where if our a is a positive, then this is the shape, and if our a is negative, then this is the shape. Okay. Secondly, this part and this part combined gives us b comma c, which is the coordinates of the turning point. So the vertex is actually referred to as the turning point, the stationary point, the highest point on a curve, the lowest point on a curve, any name you want to give to all of these exact same points. So it's either this part or this part, and there's multiple ways of saying this. There's turning points, there's stationary points, there's highest point of a curve, lowest point of a curve, and many other names. Okay. So with that being said, this b and c from this part and this part, it gives us the exact coordinates of either this or this. Okay, where x is equal to the b and y is equal to the c. I hope that makes sense to you. We're going to look at an example real quick in a bit, but I hope the equation makes sense to you, okay? I'm also going to give you like 5 seconds to write the notes if you're writing the notes with me. And if you don't have the time to write the notes, I'm going to send you the whole file anyways after the class in the WhatsApp group chat. So you can just take the notes from there if you need it, okay? And then for the third form, we have the root form. And it goes like y is equal to a x minus b x minus c, okay? Once again, this a is going to give me the shape where if a is positive, this is the shape. If a is negative, this is the shape. Secondly, this x minus b and this x minus c, these are going to give me the roots of x. In other words, they're the x-intercepts. So for example, I have something like y is equal to 2, x minus 3, x minus 7. This means this says that it's a positive curve, a smiley face curve, and these parts tell me that my x-intercepts are at 3, 7. So my curve is going to look something like, hypothetically, it's going to look something like this, where this part is 3 and this part is 7. Any questions? Is this also okay with you? Can we move on? Okay, thank you so much. Please stop at any point. Don't feel pressurized to just say okay because everyone else is also saying okay. If there's anything you'd like me to explain again, please let me. And I'm right here for you. Okay. So the next part is going to be from converting from the first one, the standard form, to the root form. Okay, or let's say to the complex square form first. So let's do standard form to the complex square form. So for the standard form to the complex square form, for this conversion, we obviously have to start with the standard form. And this is a very, very common question in the paper. Let me just write the format of the question for you. So it feels familiar when you later on do this in your actual paper. So express 2x squared minus 16x plus 44 in the form a x minus b whole square plus c. Okay, so the question is going to give you a form. They're going to give you an equation and they expect you to convert this into this. So let's break down the steps very slowly for anyone who's doing this for the first time. And if you know how to do this, I'd highly recommend that you try doing it as well, and then you match your answer with mine. Okay. So the first thing we have to do is always isolate. Let me just write the equation again. So we have 2x squared minus 16x plus 44. So what I always recommend doing is you always isolate this x squared. Okay. Whatever is in front of this x squared, you divide the whole equation with that value. So in this case, we have 2, right? So we're going to take 2 as common. And we're going to divide the whole equation by 2. So we are left with x squared minus 8x plus 22. So step 1, divide by 2. So divide by coefficient of x. Coefficient of x squared. Step 2 is going to be to isolate the x squared and x terms. So in this case, we have x squared minus 8x. Now here's where the magic happens. Okay, so you have to understand that in order to go from this to this thing, we have to have a square inside a bracket, right? Like our square outside the bracket. So the way to do this is you basically have to try to convert this into a minus b whole square form. Okay, so if you happen to recall from your IGCSEs, a minus b whole square is equal to a square minus 2ab plus b squared, correct? So this part and this part, they're basically saying that this 2 is this. Okay, So that's how it happens. That's the derivation behind it. Now I'm just going to show you the magic behind it and how to do it in a very easy way. The easiest way to solve this is you look at the value here, the coefficient of x, and you half it. Okay? So step 2, half the coefficient of x. And I'm going to try my absolute best to do it very slowly so it makes sense. So we have 2. Now what we're going to do is have this and bring this here, x minus 4 whole square. Okay? So we're converting this whole thing into this. Cool? So we took the 8 and we halved it to get minus 4, and we're using it with x and putting a bracket all over it. And then you have to recall that when you had a minus b whole square, you had a minus b whole square as a square minus 2ab plus b square, right? So there is this part as well, which you have to cater to. So let's just keep it here for now. So now we have plus 4 square. Again, just the half of this, okay? So you're adding it. You're adding a plus 4 square with it. And then what you have is you subtract the 4 square again. Again, I'm going to show you how this works. And trust me, it's going to make sense. Or let me just write one more step for you so it's even easier to follow. So let's have x square minus 8x once again. And now what I'm going to do is have this and bring it here. So we have plus 4 square minus 4 square. Okay, so I have this number. I brought it here once, and again, I brought it here once. Does anyone have any question up until this point? We're not done yet. It's just the middle of the workout. I'm just asking if you can follow my workout as of now. All we did was have the value of 8, and we got plus 4 square minus 4 square. Okay? Seeing no questions, I think we can just write the rest of the equation now. So we had a plus 22 here as well. Let's just write this as plus 22. And we close the bracket, okay? Let's get rid of the arrows. So now you can see that this part looks very similar to this part. The a square minus 2ab plus b square, where a is equals to x and b is equals to 4, okay? If you expand this, you're going to see x square minus 2, a is x, b is 4 plus 4 square. So you get x square minus 8x plus 4 square. And if you match this one with this one, you see that the exact same equation, right? So you can verify that we've successfully compared it with this whole thing. So that therefore, we can now write this as x minus 4 whole square. I hope that makes sense. This entire thing just became this because we just verified from here that x minus 4 whole square is equal to that part. Okay, so this is the mathematical explanation behind it. But even if you just recall the formula or like shortcut behind it, you can very easily solve it. You don't have to understand or like you don't have to remember the exact working or the explanation behind this. Okay, so just to recap, what we had was we had this equation, and all we did was we have this number. We added the square of that half, and we subtracted the square of that half. We just take the first half of the equation, this part, these 3 values, and we convert this into x minus 4 whole square. Again, this minus 4 whole square is just the half of this value. Okay? And what you're left off with is now this part, right? So you're left with minus 4 square plus 22. Minus 4 square is just minus 16. So you're left off with this. Now you have 2 x minus 4 square plus 6. And if you expand this, you get 2 x minus 4 square plus 12. Okay? Any questions? Takes 5 seconds, take 10 seconds even. Look at the steps and then tell me if there's anything wrong with this. No questions? Are you all okay with this? The last step you must always include is when the question asks for this type of format or like this type of wording from you, always mention the values of A, B, and C in your final answer. Just writing this answer is not going to be enough. So what I want you to do is write A is equal to 2. If you notice, this B already had a negative sign in front of it. So my B is not actually negative 4. It's just 4. So B is equal to 4 and C is equal to 12. So you have to write this line as well. Okay. This is where a lot of students lose their mark. Don't lose the mark here. You have to write this as well. And then let me give you another example. So it's a bit easier to follow. So the question will say, express 2x squared plus 16x plus 25 in the form ax minus b squared plus c. Okay. So again, let's write the equation again. So we have 2x squared plus 16x plus 25. The first step was to isolate the x squared, right? And divide by the whole equation. So we have 2 here. And then we divide that the whole equation. So we have x squared plus 8x plus 12.5. Okay. Let's fix that. Fix the bracket here. Okay. You can also write 25 over 2 if you want. Let's write 25 over 2. And then the second step was to isolate this x, whatever the coefficient of the x is, to have that, right? So now we have 2, we have x squared plus 8x plus the half of that number squared minus the half of that number squared plus whatever the rest of the equation was. Is anyone struggling to follow? Okay, so let's carry on. And then we can just take this whole part and make this x plus 4 whole square. So we're left with 2 x plus 4 whole square minus 4 square plus 25 over 2. Let me fix the brackets here as well. And if you expand this part, you're supposed to get minus 16 plus 12.5, which is, I believe, the letter C. So we have 2x plus 4 whole square here. And then we get, so we have minus 16 plus 25 over 2. And we get minus 7 over 2. And then if you expand the bracket with the 2, you are left with 2x plus 4 whole square minus 7. So A is equals to 2, B is equals to, no. Now here's the catch. This question said the B was in negative form, while my final answer has the B in a positive form, right? So my B has to be negative form. And then C is again negative 7. Sorry. Does anyone have any question? Do you all get this? Okay, thank you so much. So let's move on. Let's do an advanced version of this. Something that does not come very often in the exam, but it comes like once every 3 to 4 years. Okay. So advanced version is going to be express 4x squared minus 24x plus 48 in the form 2x minus a whole square plus b, and then state values of a and b. So as you can already see that in this question, the difference here, there's a 2 inside. So let's see how to deal with this. Okay. So once you have an equation like this, I would always recommend you to first write the equation, so it's easier for you. And then you keep on following the exact same steps until almost the last step. Okay. So the first step was to isolate the x squared. So we have 4 here, and we divide the whole equation by 4. So you're left with x squared minus 6x plus 12. The second step was to have this, and then to add this square of that, and then subtract the square of that. So we have 4 x squared minus 6x plus 3 squared minus 3 squared plus 12. And if you compare this, you should get x minus 3 whole square. So you're left with 4 x minus 3 whole square minus 9 plus 12. And let's just write this in short. This is equal to plus 3. And you're left with, okay, so now here's what happens. You have 4 x minus 3 square plus 12. This could have been my final answer in the previous question, but this time the question expects you to write 2x here. Okay, the way to do this is to write this 4 as 2 square. So you have 2 square x minus 3 square plus 12. Any questions with this step? Once you have this, you can take your power common. Okay, as you can see that this and this are common, right? Squares are common. If you did not know, if you have m to the power, let's say x, and then n to the power x, this can be combined written as mn to the power of x. Okay, so this is a formula from indices. If both bases have the exact same powers, then you can combine the bases and write one power. So in this case, since both of these have the exact same powers, we can combine these two and multiply it with this. So you're left with 2x minus 6 all over to the power 2 plus 12. And that should be our final answer, where A is equal to negative 6 and B is equal to 12. Any questions? Does everyone understand this? This part is very important. It's not tested very often. So if you do very little past papers, you're not going to go across this, or you're not going to come across this. But you should know this concept, okay? Because it's in the syllabus. I hope that makes sense to you. So let's move on. The next thing we're going to do is standard form. To the root form. If you can't recall, standard form was ax squared plus bx plus c, and it's going to get converted into a x minus b x minus c, where these are the x-intercepts, this is the y-intercept, and this is the shape. This is also the shape. Okay, let's just write this once again for your revision. So this is the y-intercept. This is the shape once again. These are the x-intercepts. Okay, so let's see how we can convert this. So let's work with a very easy example first. Let's say we have y is equals to 7x squared minus 63. Now this might seem new to you, or this might sound new to you, but in reality, this is the most basic algebra you've been doing since like grade 6. Okay, so y is equal to, all you have to do here is factorize. Okay, factorize, and your final answer should be in the form of root. Okay, so you're left with x squared minus 9, and you know that this thing is just a squared minus b squared. So you are left with y is equal to 7. If you have a squared minus b squared, this should be x minus 3 and x plus 3. I hope you know this. Please let me know if there's any confusion. I'm right here to clear that. So you're left off with this, right? And this is in very basic terms, a x minus b x minus c, where a is the shape and these two are the x-intercepts. So the graph is going to look something like this is negative 3 and this is positive 3. Any questions? Seeing none, let's do one more example for factorization. So we have y is equal to, let's say, x squared minus 6x minus 16. Okay, the way to solve this is by middle term factorization. I hope you know this. So y is equals to x squared minus 8x plus 2x, because I can see from this and from this one here that is supposed to be negative 16, right? So I'm using factors of negative 16, and then you have minus 16 here. So you have x minus 8 plus 2 x minus 8, and if you get this, you're supposed to be left with x plus 2, x minus 8, where there's a 1 in front of it, okay? So this one gives us the shape of positive, and then this and this, they give us the x-intercept. I hope you know from these examples that the x-intercept from this is going to be x is equals to -2, and from this part is going to be x is equals to 8. So our curve looks something like, oops, sorry, my bad. So we have something like this, where this value is going to be -2, and this value is going to be +8. I'm going to give you 15 seconds. Please look at the question solved here, and then let me know if there's anything you'd like me to repeat. Okay, seeing none. Let's go to the next part. Again, I'm going to give you the whole PDF of this so you can get the notes after the class. Don't worry about that. Okay. So let's learn how to sketch a quadratic curve. This more or less covers the shape and all the other concepts I was telling you about. So the first thing is always going to be determining what the shape is going to be. Okay. So the shape of the quadratic curve. So it can either be like this or it can be like this. And each of the scenarios are when a is greater than 0, as in it's a positive value, then we have this smiley face curve. Okay. So we have a positive of x squared. Let's write positive x squared here. I hope that makes sense to you, even though plus x squared does not make any sense. I hope this, you can remember this means it's a positive x squared. Okay. Similarly, if a is less than 0, that's properly. So if a is less than 0, then I have a negative x squared, right? And a negative x squared gives me a shape of this, gives me a curve of this shape. I hope that makes sense to all of you. And the number 2 is going to be the turning points, the vertex of the stationary points. Okay, they're all the exact same thing. Let me just show you. So turning point, another name is the vertex, another name is the stationary point. For each of these, you're either referring to this point or you're referring to this point. Okay, so this is found from the completed square form. Again, you can't find this directly from the root form or from the standard form. Okay, you have to must use the completed square form. So if your question gives you the equation in terms of the standard form, what you must do is convert that into the vertex form or this completed square form. And from that one, you can find the turning points. Okay. So let's see. If you have something like y is equal to 3x minus 2 whole square minus 7, then this part gives me the shape, and this part gives me the turning point. If you can recall from our lecture on that part, then our completed square, the vertex form, is supposed to have a negative symbol here, and our final answer was still just the B and C. So in this question as well, we can see that there's a negative sign here, which is absolutely normal. Okay, if this is a positive sign, then we'd be working with -2. But since it's a -2 here, we are working with a +2. Okay, so our turning point is going to be 2, -7. So our shape looks like this, and our turning point is at 2, -7. So our graph looks something like this. Does that make sense to all of you? Okay, that is wonderful. So let's move on. The third thing, I believe, yeah, we've just covered 2 points. So the third point is going to be the y-intercept. So there is one thing I want you to remember for a lot of other chapters as well. Even in future chapters of calculus or like coordinate geometry or even functions, you're always going to have to use the concept of at the y-intercept, x is equal to 0. And likewise, at the x-intercept, y is equal to 0. Okay? So you find the y-intercept from the standard form. Again, if you can recall, y is equals to ax squared plus bx plus c for the standard form. And we had told you, or like we had discussed, that this plus c is what determines the y-intercept. So if our example is something along the lines of, let's say, y equals to 2x squared plus 12x plus 5, then this part tells me that my y-intercept is going to be at y equals to 5, and the shape of this curve is going to be positive 2. So it's going to be something like this, where this line is 5, which means the curve is something like, let's say, this. Okay? Does it make sense to all of you? Okay, thank you so much. The next part is going to be for the x-intercepts. Okay, so this is number 3. Now we have x-intercepts. And another way of saying x-intercept is by saying roots of the equation. Okay, so roots of the equation, and you're most likely going to be asked to solve for the roots or to solve for the x values. Okay, so we have this, and for this, the form was the vertex form. So for the vertex form, let's say we have y is equal to 3, x minus 2, x plus 1. The way to solve this is you take these individually and you get x minus 2 equal to 0. So x is equal to positive 2, and then x plus 1 is equal to 0. So x is equal to negative 1. So now you have the shape and you have the two x intercepts. So let's say it's something like this, where is this, and this is going to be negative 1. This is going to be positive 2. Are you all okay with this? Can I see thumbs up? Okay, thank you. And if you move on now, let's work with a whole question by ourselves. So let's say the question says, sketch the graph y is equal to 2x squared minus 4x plus 7. Okay. For this sketch of a graph, you must find a couple of things. Okay. You must find all intercepts. That means the x-intercept and the y-intercept. And then you must find the turning point. Okay. So remember this. You must find the x-intercept, the y-intercept, and the turning point. And there's also going to be some marks for the shape of the curve, whether you chose this shape or this shape. Now, from this question already, I can see that this tells me that the shape is going to be like this. And this part tells me that the y-intercept somewhere around here is going to be equal to 7. Okay. So let's try doing this. One other thing you must know is a turning point. Now, the problem with that is we can't find a turning point from the standard form of the equation. For the turning point, we must use the vertex form. Okay. So we must now convert this equation into the vertex form. So we are left with y is equal to 2 x squared minus 2x plus 7 over 2. And then you get y is equal to, let's say, 2 x squared minus 2x. We are supposed to have this and add the square and subtract the square. So we have plus 1 square minus 1 square plus 7 over 2. Anyone who has an issue with how we did the completing square? Seeing no one, let's move on. So we have 2 here. We have x minus 1 square plus, okay, so now we have minus 1 square plus 7 over 2. Okay, so we are getting rid of this whole part by this equation. Please ask me any questions if you have them. I'm more than happy to help. Okay, so you must now find this. is just 3.5 minus 1, that is going to be 2.5. So you have 2x minus 1 plus square plus 5 here. Okay, I skipped on a couple of steps just to get rid of the redundant workout, but this is the final answer. Now, from this point, I know that this is the shape, and this value combined give us the turning point. In this case, it's going to be positive 1 and negative 5. Sorry, positive 1 and positive 5. So we have 1, comma 5. Again, let me give this 5 seconds, or 10 seconds to look at my workout and then ask me any question that you might have regarding how I got to this. Is this okay with all of you? So since you have the shape and the turning point, I think it's very easy to draw the graph now. So let's just sketch it. It's completely fine. Okay, so the shape is positive 2, the turning point is 1, 5. Let's say 1, 5 is somewhere around here. Okay, this is 1, 5, and the shape is going to be like this since it's a positive 2. So we are going to have something like, wait, let's fix this. We're going to have something like this. Okay, but this is the turning point, and the y-intercept is not given, but the turning, oh, I think it's given. The y-intercept was given from this part, plus 7. Okay, so this part is y7, and as you can see, there's no x-intercept because this graph never touches the x-axis, right? Since it never touches the x-axis, there's no x-intercept in this question. Any questions? Can we move on? Thank you so much. So in the next part, we're going to be working with the maximum value and the minimum value. Okay, so just a second. So we have max or min values. It's a very, very small concept and a very easy concept as well. If my a is more than 0, which means my a is a positive number, we've learned that it's supposed to be a curve like this. And in a curve like this, we only work with the minimum value, min point. Because the max point does not exist, as there's the domain given here. This will go until infinity. This will also go until infinity. Okay, so we don't have to work with those. We only work with the value that has been restricted. So it's the minimum point of the curve. Similarly, if a is less than 0, that means a is equal to negative. And if a is negative, the curve looks something like this, where this would go until infinity, and this would go until infinity. So the only point we work off is with max point. Any questions? Okay, seeing none, let's move to a couple of quite important concepts now. So we just work with y-intercepts there. Let's work with x-intercepts. Okay, so we have 3 here, we have 4 here. Let's leave it 6, 5. And just like the y-intercept concept, for the x-intercept concept, the concept is just that at x, y is equal to 0. Okay, so the value of y becomes 0. Let's work with equation and let's be introduced to an equation. So y is equal to, let's say, 2x squared plus 3x plus 11. Now, if you try solving this using the middle term method, you're not going to be able to solve this, which means you must use another formula. For the formula, what you have is x is equal to, I hope you know this formula. If you don't, you will be also finding this on the back of your paper, so it's completely fine. So x is equals to, so this is a is equals to 2, b is equals to 3, c is equals to 11. So x is equal to minus b plus minus root over b squared minus 4ac all over 2a. Any questions? Seeing none, let's just plug in the values. So we have negative b, so that is negative 3 plus minus root over b squared minus 4ac. So root over b squared is going to be 9 minus 4ac, so that is 4ac A is 2, C is 11. So you're left with minus 3 plus minus. There's a root 9 minus, there is 44, 88. So 9 minus 88 is going to be 79. Okay? So you have negative 79. So this has no solutions. But yeah, it still exists. I'm just showing it to you so you know how it works. Okay? That's the formula. That's the quadratic formula. Okay? I hope it's all okay with you. Thank you so much. So to move on, let's now work with the determinants or the discriminants actually. Sorry. So we have discriminants now, okay? The discriminants in very simple terms are just this one. Inside the formula, there was a b square minus 4ac. That is the only thing we're going to be working with here, okay? So what the formula or what the concept basically tells us is when you have the form in this format, all we have to do is just use the concept of b square minus 4ac. And then based on your number of answers, you're going to understand, or like based on your answer, you're going to understand how many numbers of answers you're expecting. Okay? So from b square minus 4ac, there's exactly 3 scenarios. The first scenario is you have one answer. Okay? So if you have one answer, that basically means b square minus 4ac is equal to 0. And your curve looks something like this, where it only crosses at 1 point. Okay? And we label this as 2 equal repeated roots. Now understand this, that there's still 2 roots here, but they have the exact same value, which is why we act as 1. So for example, if you had something on the line that's x minus 3 square is equal to, let's say, 1. Okay? No, that's a bad example. My bad. So if you have something like 4 square minus 4, 2, 2. So the equation would be something like ax square. Sorry. You have something like 2x square plus 4x plus, let's say, 2. Okay? So in this case, you have a is equal to 2, b is equal to 4, and c is equal to 2. So according to the formula of b square minus 4ac, this is exactly what you get. Okay? And as you see that when you solve this, your answers get cancelled out and you're left with 0, right? So when b square minus 4ac is equal to 0, I'm supposed to have one answer only. I hope that makes sense to you. I'm going to show you more examples, so it's going to make more sense to you later on. But I hope this part makes sense to you. Okay? So the first example was if b square minus 4ac is equal to 0, then you have one answer only. Second scenario is if b square minus 4ac is greater than 0, as in it's a positive number. Positive, okay? In this case, you have 2 answers, and you label it as 2 distinct real roots, okay? So 2 distinct, which means different. So your graph is going to look something like this, where you have this root and this root, okay? Can we move on? The distinct part means there's going to be 2 different x values, okay? So it's not going to be just one x value, it's going to be 2 different x values. So let's see the third scenario. The third scenario is going to be when I equate b square minus 4ac by plugging in the values, and the calculator gives me a negative answer. So b square minus 4ac is less than equals, so is less than 0. In this case, what happens is we have no real roots. If you plug in an equation like this into your calculator, you're going to see that the answer comes in imaginary values, or like an I. Okay? So when your answer comes in I, or an imaginary value, at that point, you must assume that you have no real roots. Okay? So this looks something like this, where the graph or the curve does not simply touch the x-axis. Hence, it has no roots. Okay? Now, the thing is, the equation still has roots. Again, here's a part of the syllabus. I'm just letting you know. So because it's important that you understand what you're learning. This question still has two roots. Still has two roots. But not real. So you see how this said real roots. That meant that it has to be a value without any imaginary values in it. But this one is going to have an imaginary value in both the equations. Okay. Can we move on? Okay, thank you so much. One more concept, a note here. If the question says okay. So this question is for the questions, or like this note is for the questions where they only tell us that it's a real root, but they don't really specify distinct or equal. Okay, that means it could either be this scenario or it could also be this scenario. Since it's a real root, as long as it passes through the x-axis, it should qualify for the condition. Okay. In this case, what you should be doing is using b squared minus 4ac is greater than equal to 0. If you can recall, this is greater than, this is equal to, we are merging them together and we are writing that is greater than equal to 0. Okay, this is only for the scenario where the only thing written in the question is real roots without mentioning whether it's distinct or equal or anything else. Okay, so let's try an example. I hope this makes sense to you. Let's just try an example before we end the class. So we have, let's say, find this set of values for which 2x squared minus 6x plus k minus 8 is equal to 0 has two distinct variables. Now, the first step always to solve these maths is going to be to look at the keywords here. So the keyword here is two distinct variables. Okay, and we know that this only happens when we have b squared minus 4ac is greater than 0. Do we not know this? We do. So let's write the equation once again. 2x squared minus 6x plus k minus 8 is equal to 0. So b squared, in this case, b is going to be negative 6, a is going to be 2, and c is going to be k minus 8. Why? Because this k is also known to be a constant and not a variable. So since this k has no x with it or no other symbols with it, we're going to consider this to be a part of c, which is the constant. Okay. Now, since the question says that it has two distinct real roots, it's supposed to be b squared minus 4ac as written here. So we can just plug in the values now. Minus 6 squared minus 4, 2 into k minus 8. And this should be greater than 0, right? Because it has two distinct real roots, which means we are using this concept. And now if you simplify this, or if you expand this, you get, from here you get 36 minus 4 2s are 8, 8k's are 8k, so minus 8k, and then minus 4 into 2, that is minus 8, into minus 8, that is a plus 64. So you have plus 64, and this should be equal to greater than, sorry, this should be greater than 0. I just forgot that. Okay. So now you can add these two parts, and you're left with, I believe, 100, if I'm not wrong. So minus 8k plus 100 is greater than 0. And if you take 100 to the other side, you're left with minus 8k greater than minus 100. And then if you bring this k to this side, you're going to have to flip the symbol. So you're left with k is less than equal to, sorry, just less than minus 1000 over minus 800. And we know that this and this gets cut off, this and this get cut off, this and this get cut off, and they're only left with 1.25. Okay, so k, therefore, k has to be less than 1.25. I'm giving you 10 seconds. Please look at the workout and let me know if there's anything at all that you want to revise. Did I mess up the values? Oh, my bad. My bad. I gave one extra zeros. Sorry. I lost focus for a second. So what we had was minus 100 here, minus 8 here. And if you simply just divide this, you get 12.5. My apologies. I was thinking of the next question already, so I just wrote a couple of extra zeros out of nowhere. So you have 12.5 here. Okay? Any questions? Seeing none, let's go to one last question before we can complete this session. So we have the question we had, let's say find the exact values of P. Two x squared plus 3px plus 4 equals to 0 has two equal real roots. So again, the first thing that I want you to learn from this question, or like learn in general, is going to be this term. When the question says exact values, you are no longer allowed to convert any thirds or any fractions into decimals. Okay? Use pi as pi, use thirds as thirds, whatever notation you have, use exactly that. Do not use decimals, do not round to anything. Okay, you're supposed to give the exact answer the way you find it and the way you use it. There's another way of saying that this is the same thing as saying it's non-calculator question. So you can't use the calculator in this question. Okay, obviously no one's going to stop you in the exam hall because no one's going to check whether you're using calculator for the question, but you should only use the calculator for checking your answer, but your workout must be very precise. Okay, so let's see. Our equation is 2x squared plus 3px plus 4 equals to 0, where a is equal to 2, b is equal to 3p, and c is equal to positive 4. And the question says that it has two equal real roots. So that means b squared minus 4ac has to be equal to 0. Any questions so far? Seeing none, let's just plug in the values. So b squared is going to be 3p whole square minus 4ac, so that is minus 4. A is 2, c is 4, and all of these should be equal to 0. Okay, let's see. So we have 9p squared now. Minus 4 2s are 8, 8 for the 32, so minus 32 equal to 0. And if you take the 32 to the other side, you're left with 9p squared equals 32. And if you take the p to the other, if you try to make p the subject, this is what you get. Therefore, p is equals to plus minus root over 32 over 9. Any questions? Do you have any questions? Are you all okay with this? Okay, perfect. I think we can call it a day for now. I'm going to send you the PDF of this, as well as I'm going to send you a couple of worksheets to practice, completely free of charge. I believe it's a very good habit of practicing topicals right after you finish a chapter, because by the time your exams come, there's a very good chance that you're going to forget these concepts unless you've practiced from the past papers. Okay, so I'm going to send you a couple of worksheets that I have from this chapter so that you can practice heavily. And secondly, as we were saying, we are going to open batches for our P1 and S1 very soon, perhaps from the next week. We are starting S1 from approximately 16 June, and the P1 is going to be announced a bit later. So what you're going to focus on is chapters that the students request specifically, or like subtopics that you want us to cover. And we are going to be covering that with high intensity as well as practice a lot by going into the great details. So if there's anything that you'd like us to cover, please let us know. And if you want to join the group sessions, please let us know as well, or you can make your parents give us know. Okay. With that being said, I think we can end today's session. Thank you so much for answering every now and then, and thank you so much for interacting with me. I hope the session has been helpful. Please provide us feedback if you want, or if you can. I'd highly appreciate that. Thank you. Bye bye. Thank you so much.